So in this lesson, I want to go over the topic of radicals. Now, what is a radical? You may have seen them before up to this point, right? Um, yeah, well, basically what makes up a radical is the root, also called the index, and we also have the radicand, the number that's inside of the radical. I don't really use that word that often, radicand, I don't know. The radicand is also, is identified by what's underneath the symbol itself. So I purposely left the word radicand somewhat not completely underneath the symbol. So let's go ahead and fix that right now. We're just gonna extend that. So in your class or in your life, you want to always make sure that the symbol is completely covering what's underneath the radical. You don't want anything hanging out. But anyway, what is a radical? Let's go ahead and see if we can evaluate without putting a precise definition on it. So what is this? What does this say? How would you read this? This is read as the square root of 81. So I don't know if you know this, but you can put a 2 here, and that's going to be helpful for us. And you're going to see as we do more examples, it's going to be crucial that we put a number in there if we don't see one. So, what is the square root of 81? For those of you who are, who are good at numbers, or, you've been through this already, you would know that the square root of 81 is 9. And that is correct because 9 times 9 will give you 81. A radical will ask you how many of that same number will give you the number on the inside, or what number times itself will give you the number on the inside, the radicand. So you're going to see some are easier than others. Some may require a little bit more work, but they can all be done. So let's go ahead and take a look at the first one. And notice I have the square root of 16 written twice. I'm going to show you one method and then show you another method. And we're going to get the same answer. We're going to get the correct answers each and every time. But I want you to choose which one works for you. So let's go ahead and take out the square root of 16. So using memorization, you know that the square root of 16 is 4 because 4 times 4 is 16. So the answer is 4. Um, but what if I told you that you can find radicals, you can find roots, you can find square roots, cube roots, fourth roots, you can find all of them using this little technique here, and you may recall this as the factor tree. So the good thing about the factor tree is that you can use any two combinations of numbers, any way you like. So what times what would give you 16? We know that 4 times 4 is 16, but let's not ruin the fun. How about we choose something else? We can choose 8 times 2. And remember, this here is it's a square root because we don't have a number in the inside. So we're going to go ahead and put a 2 here. So we're asking what number times itself would give you 16. But anyway, let's go ahead and keep on breaking down. What times what would give you 8? We can do 4 times 2. What times what would give you 4? We can do 2 times 2. So remember, this is asking you to take 2 of the same number. And once you find 2 of the same number, we're going to circle them and we're going to bring it up. And let's go ahead and see what we got. So this is the end of the factor tree, right? Like you can't break these down any further. So do we have 2 of something? Yes, we do. We have 2 2's. So let's go ahead and write our radical again. Once you have 2 of something, you can bring it out. So circle and bring it out. What else do you have 2 of? We have another 2 2's. So circle 2 2's, bring just 1 out. Notice that I'm multiplying with the 2 I already had outside. Now, is there anything left to circle? No, there is not. So remember, don't go back up the tree and look at the 4 again. 4 is no longer a 4. 4 branched off into these guys here, 2 times 2. So you don't want to backtrack up the tree. Once it's broken down, you never go back up the tree. So there's nothing left underneath the radical, right? That means that this is a perfect square where we're taking the square root. So this is considered a perfect square because there is nothing left inside the radical. So the answer here is just going to be what's on the outside, which is 2 times 2. And you know that 2 times 2 would give you a 4. So that's one way that you can do it. You can just use a factor tree. It is tried and true. Practice, and you would get it each and every time if that's the method that you want to use. But there's a different method. And yeah, we will use the factor tree, but it's the way it's presented that's gonna make the difference, and you'll see what I mean. So let's jump right in. Okay, so we have another square root of 16. There's no number here, so let's go ahead and put our 2. So we're gonna break it down again, and let's keep on, let's divide everything by 2 like we did before. So divide this by 2, we get 8 times 2. This is 4 times 2. I can do better than that. All right, this is 4 times 2. This is 2 times 2. Now, once again, we're gonna write down what we have. And now let's present this a little bit differently. We're gonna rewrite this radical. So this is 2 times 2 times 2 times 2. Wouldn't that just be 2 to the 4th power? So looking at what we have here, it's presented a little bit differently. You can argue that it's a little bit neater than the last approach, rewriting the radical completely. Now, how do we evaluate this? So in order to do it correctly, you want to take this number here and you want to divide it by this number here, your root. So look at it this way. We're going to just go ahead and divide like that. 4 divided by 2, which you know is 2. So this is your answer here. This is the exponent of your answer. So it's a little bit, just stick with me here. This is your base inside the radical, right? So you're going to take whatever your base is and you're going to raise it to whatever this is when you divide it. And you get 2 squared, which you know is 4 again. So in the beginning, it may look a little weird, but you're going to see as we progress, if whichever method you stick with, if you want to rewrite the radical or if you just want to jump right in and make your circles, it's completely up to you as long as you do something and execute it the correct way. Let's take a look at the square root of 36. I know a lot of you are screaming, hey, it's just 6. Yeah, we know it's 6, but let's go ahead and find it using one of these methods. So I'm going to go back to the circle method again, and I'm just going to go ahead and divide these things by 2. So it's 18 times 2. This is 9 times 2. This is 3 times 3, and they're completely broken up. So let's go ahead and make our foundation. We're looking for 2 of the same number. What do we have 2 of? We have 2 3s. Circle both 3s, bring one out. What else do we have 2 of? We have 2 2s. Circle 2 2s, just bring one out. Is there anything left inside the radical? No. So, technically, when there's nothing inside the radical, we just have a 1 left over. And the square root, the cube root, the 4th root of 1 is just 1. It's like it's not even there. So you can cross it out if you like. So what is 2 times 3? 2 times 3 will give you a 6. Now, is the square root of 36 equal to 6? Absolutely. 6 times 6 is 36, so we're done there. Now, let's make it more interesting. We're going to do the cube root of 64. So, in the previous examples, we always found 2 of the same number to give us the number inside, to give us the radicand. But now we're going to look for 3 of the same number that would give us 64. So what number times itself will give you 64? Now, I'm not going to spoil it this time. Let's just go ahead and jump right in. Let's see, we did the circle method last time. Let's go back to the rewriting method. I don't know what fancy name they have for it, but anyway. What times what we give you 64? We can do 8 times 8. Now, if this was a square root, you would have been able to just circle 2 8s, bring out 1. So, the square root of 64 is 8. We would have been done right there. As soon as you get 2 of the same number, we would have been done. But we need 3 of the same number. So we're not quite out of the water yet. So this would be 4 times 2. Just break everything down. This is 2 times 4. It doesn't matter which order you write it in. Okay, I like to underline what cannot be broken down anymore. It makes it easier to see. So we have 1, 2, 3, 4, 5, 6 2s. So let's go ahead and rewrite this. This is the cube root of 2 risen to the 6th power. So, is this exponent here divisible by this root, this index? Yes. So it's going to be a perfect cube. It's considered a perfect cube. Whatever you can divide your power on the inside by the root on the outside is considered perfect. It can be a perfect square, perfect cube, perfect whatever. So remember, we always do it like this. Just come to the side, just come over to the side over here and do 6 divided by 3. We know it's 2. So what's your base? Your base is this guy here, which is a 2. What result did we get from dividing? It's a 2. And we go ahead and evaluate 2 times 2, which we know 2 squared is 4. So is 4 times 4 times 4 equal to 64? Um, we can try it out right now. 4 times 4 will give you a 16. We're going to multiply by the third 4, so that's 24. Carry to 2. 4 times 2, I'm sorry, 4 times 1 is 4, plus 2 is 64. Yeah, got it. So yeah, it may be, I'm not sure which method that you all would prefer, but it can be done. Me personally, I did the circle method. I just feel like I don't know, it just speaks to me better until I was ready to start dividing the exponent by the root, the index. But anyway, last but not least, we have the 5th root of 243. So no matter how crazy this guy over here can get, um, keep the basics. You want to break it down till it can't be broken down anymore. I'm going to end it with the circle method because the circle method is not as mathematical as the dividing method, dividing by power method. But anyway, let's go ahead and break everything down. 243, what can that be divided by? It ends in 3, so there's a good chance it can be divided by 3 possibly. Let's put that to the test. So is 243 divisible by 3? Well, remember we have to add up the individual digits of 243. 2 plus 4 plus 3. And 2 plus 4 is 6. 6 plus 3 is 9. And we ask us, is this number divisible by 3? Yes, 9 is divisible by 3. So 243 is divisible by 3. So it's going to be something times 3. But what is that something? So, hey, we know it's divisible by 3, so let's just do some long division on the side. Um, you know, 2 cannot be divided by 3, but 24 can, and we get an 8. So this is 24, subtract. We have 3 divided by 3, which is 1, so the answer is 81. And now we can keep on breaking down the numbers. So 81 is recognizable, right? That's 9 times 9. Or any combination you want to choose. You can do 27 times 3 or whatever you like. That's the beauty of this method. And just keep on breaking down completely. So we have 3 times 3 times 3 times 3. Check it out. We have 5 of them. So check out this ugly circle. Circle all 5 threes, bring out 1. And there's nothing left to circle, so we're done. And that's all there is to it with radicals. I know they can look a little crazy. They are crazy, but I recommend you start off with the circle method, like I did. It worked for me until I was ready to do the division method, and you're done. We're finished. So thank you very much for watching, and have a wonderful day. Like and subscribe.